Hello class, welcome to Pre-Algebra Lesson 9.4, which is all about negative exponents. By the end of this lesson, you should be able to write expressions using negative exponents and evaluate expressions containing negative exponents. Alright, so some vocab. A negative exponent for any non-zero base, a to the negative n power equals 1 over a to the n. Yesterday we talked about this a little bit. We practiced it a little bit with our IXL skill, but let's just dive deeper into that. So if I have this example of 2 to the negative 4th power, this would become 1 over, you keep the base the same, but then you change the exponent from negative to positive. Okay, so it started as an invisible fraction, right? A fraction over 1. And then to make that exponent positive, you move it to the other part of the fraction. So a lot of you are going to be tempted to leave your answer right there, but today we're going to practice where you actually figure out what is 2 to the 4th power. And 2 to the 4th power is 16. So you would rewrite this fraction as not just 1 over 2 to the 4th power, but 1 over 16. Okay, so that is what we're going to be focusing on today. Okay, so then here, let's evaluate some exponents. This is something you did just a few lessons ago. If I type in 5 to the 3rd power, remember, I do 5, I use the caret key, then I hit 3. And when I do that, I end up with 125. 5 squared, or 5 to the 2nd power, is 25. Remember, that's just saying 5 times 5. And this top one was 5 times 5 times 5. And 5 to the 1st power is just 5. Anything to the 0 power, we haven't talked about this yet, but anything to the 0 power, if you try plugging that into a calculator, anything to the 0 power always equals 1. Okay? And that goes for, even if it's a variable, if it's like x to the 0 power, that still equals 1. Because it doesn't matter what number is to the 0 power, it equals 1. All right, and then if we have 5 to the negative 1st power, that would be 1 over 5 to the 1st power, which is just 5. And then 5 to the negative 2nd power becomes 1 over 5 to the 2nd power, or 1 over 25. So you should be able to see that there's a connection, right? 5 to the 1st, 5 to the negative 1st. And then 5 squared and 5 to the negative 2nd power. You can see that they are just kind of opposites of each other, right? So remember, negative exponents, to make them positive, move them to the other part of the fraction. So here I start with 2 to the negative 3rd power. And if I want to write that using positive exponents, I would write 1 over 2 to the 3rd. And then I can evaluate that. 2 to the 3rd power is 8. So my final answer would be 1 over 8. Okay, number 2, I have m to the negative 16th power. So I'm going to move that negative 16th power to the bottom of the fraction. And since I don't know what m equals, I'm going to leave it as 1 over m to the positive 16th power. All right, what if I wanted to go backwards? What if I wanted to change it from this fraction to something written with a negative exponent? This would become 4, and if I want it with negative exponents, this would be negative 6. If I have a 100, you can either say 100 to the negative 1st power, or some of you might know that 100 is 10 to the 2nd power, so it can be written as 10 to the negative 2nd power. Okay? This is something that you should strive to get to. If all you can see is this for now, that's okay, that's a good start. But our goal is to be able to spot things like this. Okay? And then 27, again, that's another one that you can say 27 to the negative 1st power. Or what number, if I test, if I think of 27, I think of, the prime factorization. We did this a couple days ago. 3 times 9, and then 9 breaks down into 3 times 3. So I have 3 3s. So this is saying 1 over 3 to the third power, or 3 to the negative third power. So this is what you should strive for. Okay, and that's the same thing here. 100 breaks down into 10 times 10, which works into a nice, perfect square. Yes, 10 could break down more, and you could do 2 squared times 5 squared, but that's going further than you need to right now. All right, let's look at a word problem. Geckos have tiny hairs on the bottom of their feet that are 0.000001. Write the decimal as a fraction and a power of 10. Okay, so this is kind of starting to introduce what we are doing tomorrow, but this introduces it nicely. So if I have 0.000001, so I have 5 zeros, I have to move this. Okay, so what I can do, if I want to write this as a fraction, this would have to be 1 over, and then 1, 2, 3, 4, 5, 6. So I could write it like that. Okay, we practiced that a couple of chapters ago. And then that would be, let's see, 10 times, again, 10 times, and then, and you could keep going, keep splitting this up. So that's 1, 2, 3, 4, 5, 6 tenths. So that's 1 over 10 to the 6, or 10 to the negative 6 power. Okay, so that would be your number as a negative exponent. One really easy way to tell this is if you just have zeros and ones, you know it's going to be 10 is probably going to be your base number. And then look, 1, 2, 3, 4, 5. I moved it 6 places. I have a 6 for an exponent. Okay? Now let's practice evaluating. So evaluate m to the negative second power if m equals 4. So let's start by writing m with a positive exponent. And then let's replace m with the value we are given. So I have 1 over 4 squared, which is just 1 over 4 times 4, or 1 over 16. Okay, so you're just plugging numbers in. I recommend always changing any negative exponents to positive before you plug things in to evaluate. So then here, I have 4 times a to the negative 5th power. Since that 4 doesn't have a negative exponent, I leave it on top of the fraction and just move the variable with the negative exponent. So I have 4 over a to the 5th. And then something to be really careful of on your calculators is anytime you plug in a negative number, make sure you use parentheses, okay? So if I plug on my calculator negative 2 raised to the 5th power, I end up with negative 32. And I have a 4 on top. So if I simplify that, that becomes negative 1/8. And that is my final answer. All right. Our last example for today, we have 6m n to the negative 4th. Again, only the n has that negative exponent. So I leave 6m on top and I write n to the 4th power on bottom. Now I replace these numbers, or these variables, with numbers. So instead of m, I'm going to write 4, and they're being multiplied up top. So I have 24 on top. and then I have 3 to the 4th power. 3 to the 4th power is 81. And now if I simplify 24 over 81, they are both, divisible by 3 for sure. So 3 goes into 24 8 times, and 3 goes into 81 27 times. And I don't believe that there are any other numbers that can be, or any other part that can be reduced there. So my final answer would be 8 over 27. Okay, if you have questions about this example or anything else from the video, please don't hesitate to reach out and ask for some help. I am happy to help you. I hope you have a great day.